Hey everyone, welcome back. This is Professor Xiao. The purpose of this video is to help you with a specific homework question. The question is hands-on practice, so let's go to a Jupyter notebook. All the demos in this video is based on the dataset YULP1. This video may use some of these packages, especially RE for regular expression, GenSim, and scikit-learn. Note that I use the NumPy random seed 1 and random state 1. After reading the dataset, here is a high-level information about the dataset and the columns included. I printed the first 10 rows of the data by selecting a few columns. We will be focusing on the review text column of this dataset, which includes each of the review texts. The first review text, the second review text, and such and such. Each review text is referred to as a document. This is how NLP programmers refer to the texts, and the entire column of review text will be called a corpus. Now let's look at a specific problem. The focus of this video is the bag of words model, and specifically on how to understand the feature vectors matrix, which is also called the term frequency table. The demo in this video assumes that you have followed 2 other videos on how to clean and prepare or pre-process the YULP review text corpus. So for the demo, I will use the review text column in the data frame df2. To run the bag of words model, you will need count vectorizer object from scikit-learn. So make sure you run and load this library. I have already run this on the top, so I don't have to do it now. A special note about the count vectorizer. You can see that I built a custom tokenizer here. This custom tokenizer simply get a string and split the string by only using white spaces, including spaces and tabs and such white spaces, not punctuations. So this tokenizer will potentially retain all the punctuations. The reason I use this custom tokenizer is because I have already cleaned and prepared the data in the review text. So I don't need a regular tokenizer which has the capability of removing the punctuations. All the irrelevant punctuations have already been cleaned and excluded. However, recall that in lemmatization, we included the POS tags. Those POS tags provide unique contextual information about each of the terms. So I would like to retain them in the bag of words analysis. So each term will include the POS tag as part of its term when I construct the bag of words model. The regular tokenizer will recognize the slash symbol and break up all the POS tags from the terms. It is something that I don't want. So I have to provide a custom tokenizer to replace the default regular tokenizer when I use the count vectorizer. So make sure you run this. Now I'm ready to train the model. Keep in mind that count vectorizer is a model object from scikit-learn, very much like any other model object from scikit-learn. So you need to create an instance of the model object with the necessary arguments. Here, I requested that this model do not convert all the texts into lowercase because I have already done it. I provide the custom tokenizer as defined earlier to the tokenizer so that it will avoid using the regular tokenizer. The maxDF argument is quite important here, and it will affect the result dramatically sometimes. MaxDF means the maximum document frequency of the terms or features. A maxDF of 0.3 means that only those terms that appear in not more than 30% of the documents will be retained. Anything that appear above 30% of the documents, which is 30% of the review text in the dataset, those terms that appear frequently in many of the documents will be excluded. The reason of doing that is exactly the same as the reason that we exclude the stop words. If a word or term appear too often in almost every document, it becomes not meaningful to text mining. The choice of 0.3 as a max df, however, requires some trials and errors. The optimal value for this argument will depend on a specific data set, the specific project, and specific problem. And max features limit the number of terms or features to be retained to the top 5,000, just so that it will take less time for the model to run. So the result of the first line of code will simply create an instance of the model without being run. The second line will fit the model to the data in the df2 review text, which is the prepared and cleaned review text data from Yelp. The fit procedure will create a vocabulary list using the terms from the review texts, the corpus, after satisfying all of these conditions that are specified for the model. So that's what the fit does. It simply creates a vocabulary list and assign index numbers to them. It's also known as a dictionary, but you haven't transformed the data yet. The transform part will use the vocabulary list to transform the original corpus data into a matrix, which is the feature vectors matrix, also known as the term frequency table. It will be stored in Z. So let's run this code. So to recap, this count object is an instance of the bag of words model. It has been trained and it has been used to transform the original text data. It returns a term frequency table, Z. So to be sure, Z is the term frequency table. It's a sparse matrix because there are thousands of columns in this matrix. How would you understand the meaning of the term frequency table? What are the columns and rows, and what does each of the cells in the term frequency table mean and measure? I will explain these and demonstrate that in a different video, so check that out. This concludes this video. I hope you enjoyed it. See you next time.